Dear students, I welcome you all for this online refresher program for the course ME 22710 Industrial Robotics Theory and Practices. So, in this short semester, we just learned this particular course through our regular classes. But in order to help you for the case of enhanced online learning as well as for the case of knowledge enrichment, these online videos have been recorded and it is uploaded with respect to the working or the programming of the robot, especially for the Mitsubishi 6-axis articulated joint robot. So 6 exercises have been planned in this regard with respect to online recording. So first it is going to be linear interpolation as well as the programming concepts, followed by the basic introduction to RT toolbox, then followed by the subsequent exercises we'll be learning in the next series of lectures. Okay. So with this basic understanding, now we'll directly get into the task what we are going to do for the first case. So linear interpolation means, so linear interpolation basically it is going to be like this. We have got one point, let me call this point as 1 and let me call another point as 2. So it is moving from one point to another point. So that is the main essential activity. So what basically we do here is, we are going to program the robot in such a way that it is going to move from point 1 to point 2. So that is what it is going to do. So from first point, it is going to travel to the next point. So likewise, we are going to go ahead. So now the task, before we get into the task, we'll just understand the question. So program an articulated robot, 6-axis robot to move around a rectangle of size 100 by 200. So now the thing is, there is going to be a path that is say 4 points and we are going to program the robot. So now we'll just get into task. So now this is point P1, P2, P3, P4, that is 4 corners, 4 vertices of the rectangle, and the distance linear, that is lengthwise it is going to be 200 and on the width it is going to be 100. So now let us see how to do the task. So before we get into programming, we should know one crucial part. How are we going to do this? So there are two distinctive steps are there. The first thing is, we are supposed to declare the point. So it is called as point declaration or point definition. So this is going to be the first. So what does this point means? It is none other than the coordinates. We are supposed to specify the coordinates initially. So this coordinates, let me call this as P suffix n. So n number of points we would have specified. So what are we going to do with this particular n number of points is, these points will be collectively programmed. So there are two distinctive steps. So the first step is, we are supposed to declare the point, and second step is, we are supposed to go ahead with the programming of those points. Okay. So with this basic understanding, we'll start. So now, initially when we start, the robot will be in some particular point. So that point has to be called as P home, because that's the default point where the robot is going to be. So now what will be our crucial task is, we will be getting into the area where are we going to do the programming. So now on the aerial view, now this is the robot. So let me consider this as the robot arm. So likewise the robot arm is there. So from this particular axis, we have got 4 portions, A, B, C and D. Whichever the point we want among these 4 quadrants, any quadrants we can go ahead. So always try to select the portions nearer to the robot point. Why? Because we might be facing the dead zone problem. The dead zone means beyond one particular point, the robot will not go ahead with. So now we'll see how to declare the points. So now this is going to be P home. So now I wanted to do on the B quadrant. So 4 points I am plotting in such a way that they are to the requisite dimensions. So now let me call this point as P1. So this point as P2. See, there is no hard and fast rule that like this only you are supposed to go. Even you wanted to have this as P2, yes, very well we can go ahead with. So it is purely our own understanding. So how to go ahead with. So this is going to be P3 and this is going to be P4. So now it can be straight. All these things can be straight. So it is purely left to our thing. So now once you are done with this, so go ahead with writing one simple table like this. So P1, P2, P3 and P4. So the easiest way is, please go ahead with a table. So write down there X, Y coordinates. So xy coordinates has to be noted down. So now xy coordinates, say for example, I'm just assuming, so this is 470, 0. So now I wanted to go ahead with the same case. Say I wanted to have some gap here. Say this particular point, y I wanted to have the same thing. So P1 will be say 520. So this point is 520, right? Okay, 50 mm I have kept the gap. So now this will be 200 mm apart. So that will be 720, 0. So next will be 100, no? So 720, 100, and this will be the last, that is 520, 100. So likewise, we should get the points. So I will just write down here. So this point is going to be 520, 0, and this will be 720, 0. So I want you students to recollect, always x will be coming first and y will be next. So that is the pattern. So here it will be 720, 100, and this will be 520, 100. So likewise, we can go ahead with the part. So once we are done with this particular activity, now we'll go for the program part. So program part, see, when we wanted the robot to move in straight line, the command what we use is MVS. When you want the robot to just move, we are going to use the command called as MOV. So these all are the two things. So let me write the program. So the first step will be move P home. So wherever the robot is available, we are asking the robot to come to the home point. Then move directly to the point P1. So from P1, we want the robot to move straight. Clear? So what I'll do is, I'll just I'll write from beginning. So the first case is so move P home will be the first work. Then we are asking the robot to come to the first point P1. Then from there we wanted to move it straight. So MVS to P2, then MVS to P3, then MVS to P4. So now the robot has moved to all this point. You wanted to go back to P home, you can go ahead, or you wanted to stop the program here. So two options are there. Either you can end the program or you can halt the program. So this is one simple program where we can go ahead with operating the robot. Okay. So with this basic understanding, so we'll just directly get into the software, how to work in the software. So when you first open up the RT toolbox, so we are going to get a window like this. So how to go ahead with the activities. So on the top left corner, when you see, you can see there are certain options are there and everything is in disabled condition. So how to enable them is, so you can see there is an option called as new. So this new has to be nicely noted down. So this particular new, you are supposed to go ahead, and here you can see the mode is in offline, online, simulator, everything is in disabled mode. So how to go ahead is, so on the top left corner, I'm just clicking new. So what I will do is select any one particular, you just select folder, not select folder, we are supposed to define the folder. So I'll just go ahead with say ME22710. Okay. Now what is the next step is, it will ask for the selection of the robot, which robot we wanted to go ahead with, and there are 8 activities are there, but initial 2 will solve the purpose. So robot name, so it is in RC1, so let it be as such. So we'll just go for next, then select the proper robot. So our robot is RV vertical type 6-axis and our payload is 8 kgs. So RV8CRL-D is the robot. So once you see the robot in this particular window, just finish it off. So now it will ask you for one important thing, how you wanted the robot to be operated. We wanted to go ahead with simulation. So the moment you give simulation, see, you need to know here on the bottom left you can see it is showing as offline mode in yellow, and here you can see there is another yellow tab in the bottom. So everything will get changed. So I am just going with online. So I want you to observe this changing. So it is go to online. Actually it is not online. I'm just to show the difference, I just wanted to do it. So we wanted to use it as simulator. So everything will become blue. Clear? And one more window will be opening up. Additionally, one more window will be opening up. So these all are the symptoms that the system is correct. So bottom left you are getting simulation, and here there is an RC, another controller has opened, as well as there is a spark like thing, that is, and window has popped up. So this is the thing. So two more panels have come. So the first panel which I am showing you right now is called as operation panel. Let me close this deliberately. I'll show you how to recover it. And you can see 3D monitor. Just expand it. Okay. So this is the robot for which we are going to do the program. So there are how to maneuver, how to move ahead with this is, see, you need to understand mouse is having certain options. So the mouse, when you see left mouse button is used for tilting. Okay, you can rotate 360 degrees, you can rotate. Then right, when you use the rise mode button, you can pan it up. Okay, so scroll is for the case of zoom in and zoom out. So these all are the basic activity. So now let me keep the robot in the top, and I want you students to recollect the thing what we just had the discussions in the earlier case. That is, we'll just go for the 4 coordinates. Okay. So I told you there are 4 quadrants are there. So on the robot, when you see from the top portion, so this portion is going to be called as that is the first, that is A, and this is B, and this is the C, and this is D. So which portion you wanted to go ahead with? So clearly you can observe, so the bottom of, that is this half, will be suitable for us for the case of smooth working. So that's how it has to be planned. Okay. So now coming for this operation panel. So as I told you earlier, how to recover the operation panel means, so it is like this. So top left you can see there is 3D monitor, and within which RC1, that is the robot name what we have chosen, and followed by simulation. So under simulation, what we are going to do is just click it up on the arrow. So here you can see operation panel. Just double click it, you will get the panel. Okay. Now the next thing is, apart from that, even there is another option called as, so on the top left you can see, and adjacent to the home there is an option called as online. So below online also you can see there is an option called as show hide operation panel. So even by clicking this also we can do. Okay. So these all are the basic things. So now we'll get into the programming part. Okay. So first you just go ahead with, we learned how to go ahead with the opening of the robot, simulation, everything, simulator mode, everything we saw. So now we'll get into the program part. So first thing is, below the simulation there is an option called as program. Double click it. So it will open another window. So give the program name what you wanted to have. So I'm just giving it as exercise 1. The moment we give exercise 1, you can see another tab has opened. See, earlier we were in this 3D monitor, and now we are in the another monitor. See, here you can see there is another tab. This tab has opened up. So now what we'll do is, this is the 2 parts what I told you. So this part is going to be purely for the program, and this part is going to be, the below part is going to be for the case of giving out the coordinates. So here you can see which coordinates are we going to use. Are we going to use the joint? Are we going to use the XYZ, or are we going to use the coordinate of combined? So here always we work with Cartesian coordinates. So first let us add the point. So add. So default it has given some points. Okay. So default it has given. So this default points are nothing but the important thing of home. So this you should know. So I am just giving it as P home. So this value is 469.970. So now let us round it off to 470. So 470, 0 and Z855 is the default home point. Okay, so this you should know at any point of time. So now we'll add another coordinate. So P1. So if you want it even from that point also we can go ahead with, but as I told you, in order to differentiate we'll have little bit away. So P1 I have defined, but I have not defined the coordinates. So 470 plus 50 away. So 520 comma 0. So recall the things what we discussed in the PowerPoint presentation ahead to this software. So the same thing I am doing. So next is P2. So what you are supposed to do is add. First add the point, click somewhere. So that point will get registered. Now you can go for the editing of the coordinates. Don't do both this at the same time. Okay. So the next point is from here we just wanted the robot to move by 700. So therefore the next point will be 720. So I am adding a point. I am naming the point as P3 and I am just clicking it somewhere. I am not doing the coordinate editing. Now let me edit the coordinate. So this point we know it is going to be 100 mm away from 720 on Y. So Y I'll change it to 100. Now the last point P4, just name it, click somewhere. Now you can go for editing. So this is going to be 520 and Y axis will be 100. So now 4 points have been declared. So this is called as point declaration or point definition. So now we'll come for the robot programming. So type MOV. So default the software will be showing the available options. So even you can directly pick up. See, have a keen observation with respect to the color. What are the color you are getting? See here you can see the color is in blue. Certain things will be black. Okay, so you should not have error. Why? Because the software will not show you errors at any point of time. Once the moment when you save, it will show you a syntax errors. Till then the software will not show, and not like any other say C++ or Python or something like that. Even CNC also, of course, we have got the software or the controller will give you a hint. This is where the error is, but here nothing. It will not show anything. So you are supposed to be very careful. And another important thing is the coordinates, everything are case sensitive. Here I gave the P home capital P and rest everything is small. So the same way it is supposed to be. So now you can see how it is. So blue color you can see that is move, that is command, and this is P home. Okay. So no end of block, nothing, just give enter. So now you can see now the second line came. We have not numbered, it came automatically, just enter. So now we wanted to move. I am just giving everything in the small case. Okay. But automatically when I give the space bar, it clearly it just goes ahead with the. So as I told you, commands are not case sensitive, only the coordinates are case sensitive. So here P1. So we want the robot to come to the point. Now we want the robot to move straight, right? So MVS straight to the point P2. So the same thing, MVS to the point P3, then MVS to the point P4, and so finally P4 is done. The last step is I wanted the robot to go to P home. So it goes to P home, and finally I want the robot to halt. So I'm just giving it as HLT. Okay. So what are the things we did is we chose the robot. Then the moment we came for the robot programming, we declared the points or defined the points. Then using these points, we just programmed everything. Okay. So now give Control S. The moment you give Control S, that is what are the program we have created under number, that is a file name exercise 1. We are going to just save it. So we are saving it up. So next step is come to 3D monitor. Keep the robot in the comfortable position. Now we are supposed to run the program. Okay. So come to the left, open the operation panel. See, operation panel, you just go ahead observing all these things. What all are the things available in the operation panel is, what are the basic activities of a robot, what we see in the real time, everything it is having. Okay. So first thing is you should have a glance on this SVO, that is servo on, servo off. So here you can see there is a yellow light glowing. So that means the servo motor is in on. So the moment you click off, yes, the button is, that is the motor is going to get off. So start, stop, reset, end, and here you can see program and select. So that's what we are going to do. I'm going to just select, okay. Select the program. So this was the name what we did, and after writing the program, even we saved it, okay. Then give okay. So you can see everything has come to the point. Now we'll just give start. Now the robot is moved. So just that is, we just ask the robot to move by 4 times. So now what I'll do is, I'll do a minimum editing in the program. I'll come back to this. I'll remove this halt. Okay. So it will not execute. Why? Because we need to save it. So Control S, save. Now I'll come to the robot, start. Okay. So this is the simplest case of operating the robot. So with this, we learned how to do the programming of the robot with respect to the coordinates. Okay. So with this, we just finish this particular exercise. So now you are done with this particular part. So next we'll get into the circular interpolation in the next presentation. Okay. So thank you, students. Thank you all.